what I love about showing is that, like, even when I was you have to do a risk assessment, and if you take that risk assessment and you do look up and you look for power lines, then you can make sure that you're using something like, as you just passed me what's behind you, shock stop.
I get to.
So you can throw this one around. This is the number 8 section. We finished what we used to do plus C or XT. If those of you go back with us like 6 or 7 years, and we changed out to a Kevlar 5-foot sleeve or extension. Right, so you can add this anywhere on a reach of pole as a sleeve or extension using connect. Doesn't matter how much you've taken the pole apart, which we'll show you later. But anywhere if you need and you feel like you're unsafe, then you can defend yourself as best as you can in the unlikely event that you fail to protect yourself from the power line and you touch it or it arcs or whatever. But then you've got to remember, if you have got electricity coming down and it has contacted you, your pole, it will go somewhere to Earth. Right? So if I've got my pole inside here and I've got my foot there and it's touching a power line there, it's quite likely it'll go through my foot. Okay, so it's not, it could save your life, but it's not like total protection, and it's certainly not to be taken like blah blah blah, I've got my shock stop, I can do it. No, no, no. If it was water running down the pole, like the water could carry the electricity. There's so many, we're going to do our best, right? So, catch. Good. Oh, great. Pass it around. And then if you could drop it over to the other side so you can feel it, because or pass this one around, right? So it's like crazy light. It's a beautiful extension, 5 feet. So all of the tactical packs, all the Warrior packs come with shock stop as standard in a pack, and then you can slide it over the top of the sleeve, or you can use it as an extension, a 5-foot extension. So Warrior is, Tactical is 25 feet out of the box. The other manufacturers would normally call us a 30-foot pole or a 33-foot, depending on how much BS they're going to load on you. So basically, they're going to add your height and sell it back to you. Right? So if this is 25 feet, they'll say it's 30-foot reach, because they're taking 5 feet of your height and adding it to their pole and saying that's what you're buying, but it's not.
So in your case, it's a 6-foot.
Yeah. So we try and give you the truth in marketing. Also, it's a 25-foot pole with a 5-foot extension and the shock stop, 30 feet of pole, plus the operator's 35-foot reach. Then you've got all the data. Yeah. And then Warrior is 10 feet longer. So what do we do? If you were only ever working at 25 feet, would Warrior help you? No, right? Because if Tactical is rigid enough, right? So if that can pick up a 16-inch brush and hardly flex, right? Then making a more rigid pole isn't going to help you anymore. If it's rigid enough, it's rigid enough. So you only want to buy a better pole if you're going to work higher. And then Tactical, we haven't got them here, have we? Have we got plus A, plus B at all?
I don't think so.
Okay. So we have extensions in the reach of range which will double the length at any pole. So Tactical will go to 50 feet plus the operator. Warrior will go to 70 feet plus the operator. Yeah, with plus A and plus B. So what's going on the inside of this? Well, carbon fiber, normally you see this surface here or a slightly different version of it. And that's what we normally relate to as carbon fiber, right? But it's called 3K. And there's 3K, 6K, 12K, and when you see different carbon fiber products, you see different prettiness. You know what I'm pointing to? The surface, right? So somebody will say, oh, it's a 3K pole or whatever. It's not. Well, it shouldn't be, right? Because what you're seeing there is, this is called twill. And you're seeing, can you see the lines going across like at 45 degrees, right? On the other side, there's lines going across at 45 degrees the other way. So you've got a 90-degree weave, yeah? It's just a piece of fabric. It's no different when it comes, before it's made into a pole, it's this kind of softness, almost, a little bit gooey because it's full of resin, yeah? So the 3K surface, the function of that is to bind the pole together and stop it from delaminating, because if all the fibers on the outside edge are going up the pole to give it its rigidity, if you did chip it, it would just, there'd be a whole line of carbon fiber that just strip off it, right? So we put 3K on the outside as the final layer. But does the 3K add to the stiffness of the pole? No. Right? Not the same as what's called unidirectional. So if all the fibers going up the pole are like my fingers, right, they're all going up the pole, Then all the rigidity, all the MSI, like whatever jargon you want to talk, but the rigidity of the pole is given to the pole by the fibers that are in the direction of the pole. That's carbon fiber, right? However, if we made, these are 8 layers, right? The top one is 9 layers. Each layer is the thickness of the human hair, 0.13 millimeters, right? So you add that up and multiply it and sand it back, and then you get like what is the reach of laminate plan. But if all of the layers were all unidirectional, you could just stand on and crack it and it would just go just like that. So we have to have some layers going this way to give it what's called hoop strength, yeah? To give it its strength as a shape, so that it can support the majority of fibers going that way, right? And 3K adds to that, because half the fibers are here, half the fibers are there, wrapping it up, okay? But from a rigidity point of view, you lose half the rigidity of that layer by putting in a weave. Make sense? Because the rigidity is driven by the direction of the fibers, or the vector direction of the fibers. So if it's 45 degrees, you lose half. 45 degrees, you lose half, but half plus half is 1. Right? So that's the logic of the carbon fiber pole. So then, now we talk about a residential pole like tactical. We can make it out of half fiberglass, 20% fiberglass, 80% fiberglass, or 100% carbon fiber. Most of the poles you buy for residential, we're looking at 20 to 30 feet. There's no way, no matter what they tell you, there's almost no way to 100% carbon fiber. Right? They'll be adding layers of fiberglass. Fiberglass is thicker than carbon fiber, so 1 layer of fiberglass is 2 layers of carbon fiber, and it adds flex and weight to the pole. But if you're only working at 20 feet, as a rule, you won't really notice. If they sell you a really light brush, you'll definitely not really notice. Because if you put a heavy weight on the end of the pole, you're going to know. That's why I want you to see this with a 16-inch brush on it, and not a little 10-inch brush, like a little Gardner thing with no bristles. You know, like any pole is going to look stiff if it doesn't have any weight on it. The question is, can you make a pole show a pole is stiff by putting weight on it? Yeah. And we were talking last night. It was one of the tests we had to do for the Israeli SAS. We had to actually make a pole, right, that we could demonstrate at 50 feet with 5 kilos on it and be able to control it. Right, and they were using it. This is the time where they had the terrorists in the hotels. It was kind of like that. Do you remember that? Those of us who are older. Right, so this pole was to run a rope ladder up, and they put these hooks on all the windowsills and all of the hotels, the 5-star hotels, and the police could, you know, extend a rope ladder up and then remote control drop it, but they could hook it on a windowsill anything up to 5 stories. So we made the poles for that. Yeah. So the rigidity of the pole is driven by, same as we talk about the rubber. There's what we could say in a marketing sense is an intermediate modulus, a high modulus, and an ultra high modulus, and a super ultra high modulus if you want. But in actual fact, it's 24T, 40T, 46T, C800. Like there's all jargon names actually sitting behind these marketing names, which anybody can use, and there are no definitions. So we would say to you as a customer, this is intermediate modulus, and this is high modulus. But if you added plus A plus B, we would give you high modulus plus A plus B, right? Because we're going to extend the pole longer. So what we put in the pole adds more rigidity to the pole. And if you bought a Warrior and you wanted to add plus A plus B for this one, we would give you ultra high modulus extensions, because you're going to go to 60, 70 feet, and you want to increase the rigidity of that pole, with a higher modulus carbon fiber. But if you're never going to go to that height, there's absolutely no point in making a Warrior out of ultra high modulus carbon fiber, because you won't see a difference. Okay, so carbon fiber, layers, materials,
section length,
overlap, right? So all aspects of design, and then, so for example, if I wanted to make this pole behave more rigid, I could increase its overlaps. Yeah, and that makes a difference if you're going out to 50 feet and you don't need to go to, well, you're going to 55 and you don't need to go to 55, then the thinner layer, the thinner tubes will flex more than the bigger tubes. Does that make sense? It's like a sidewall effect. Yeah? So thinner tubes will flex more than thicker tubes. That's why our top tube is 9 layers, right, to get it just more rigidity and being thicker, right? So it's less of a liability on the pole. And then the longer the section, same as we talked about bristles, right? The longer the tube, the softer it will behave. The shorter the tube, the firmer it will behave, right? So there's some benefits in having, short length tubes. Big handle. The handle is big, but it's like from the Harvard studies from the squeeze grip of the average Caucasian male. It's exactly right. So that is what your hand should be gripping, and then that gives us the ability to have shorter sections, more rigid pole, and then we're going to talk about pull apart after that. But I do want to show you, and then let you have a chance of picking these up. Peter, you can pick up the Warrior, right? Because you go on that side and I'll go on this side, yeah? Are you good? Your back's good?
Oh, yeah.
Alright, so...
You got this wire.
Like, I just want to say,
Yeah, right.
you look at my fulcrum point, I'm not... I can make a really big difference.
You struck me to it?
That bastard.
Right, but
He's got you.
Like I'm
Pretty hot.
putting the half out.
You put him on the side with wires.
Oh, did
I want to be safe.
You have wires?
Yeah,
On this side here. For the
LED lights.
Oh, shit. Good enough.
Yeah, where's your shot sleeve?
So, like these have both got 16-inch brushes, which other people may, by the way, call 18-inch brushes, because some of the manufacturers actually splay the brush and then give you the dimension, right? And we give you the block dimension, just so you know, like how stories are told. Yeah. You ready? 3, 2, 1. You're pretty strong, buddy. Right, and then this morning we covered, just for those of you who didn't get it, like the weight of this pole is just whatever it is, 2 kilos or whatever, but that's like crazy easy to control, like when it's vertical, because gravity is just pulling down on its mass. And then the more we lean that over, and that's what the problem with rinsing off glass, is you start trying to control this pole and you get tired and your brain freezes and fries, and then you're trying to rinse and you're all a torque and your groin gets damaged, doesn't it? Yes! Okay? So, and the hardest part is to be able to hold a pole at horizontal, because that's the maximum effective gravity on the pole. Right? And anywhere in between is your inheritance. Can you hold it horizontal? There you go. Yeah. So, and then you guys can kind of memorize that and have a go, like, and pick them up and then sort of compare that to what you're using now. But remember what the weight of the brush is on the end, or take the brush off and try it out. But it needs weight. Actually, it needs weight to flex these at all. Because otherwise they're pretty much rigid. Both of them are under the same conditions. Yeah. My force, you can see where the apex changes or starts. Yeah. So the apex starts at the top of where, like if you see a curve and then you draw your straight lines and then there's an apex there. So the apex is near the top. And then, I'm going to get really scientific, but the point will be simple. So let me try and get to the point. The higher you take this pole, and when it first flexes, it'll flex near the top. Right? Then you'll go up another story, and the flex point will actually move down the pole. Then you'll go up another story, and the flex point will move down the pole. Right? So it doesn't just flex at the top and then go straight. The flex is consistent, so the longer the pole, the further down the pole the flex point comes, right? And obviously it flexes more with the thinner tubes than it does with the thicker tubes, so it doesn't come to the middle. There's more flex at the top than there is at the bottom. So what I was trying, I thought all the other things. I used to have a Land Cruiser and it had a stiffening kit in it. She was an old girl, so we had to put a spring kit in it. And so we thought about how to strengthen the pole where the pole was flexing would mean that the pole would give you the rigidity that you need to maintain your precision and accuracy that you want in order to clean windows quickly. Yeah. Otherwise, you're losing all your effort in the flex, right? And that's calories. Like flex is heat. Yeah, you can't feel it on this, but if you just bend some number 8 wire, or those of us who grew up on farms and you know have to do that, or change a fuse or something, you get a little and then your fingers burn. Like so, flex creates heat. So when you see a pole flexing, it's actually your calories being lost. It's not helping you at all. It is completely a loss of the food that you just ate into flex, and then rendering you less effective. Yeah, completely. So what we want to do is we want to stiffen the pole where it's flexing. So when you look at a reach it, the plus A goes there. It goes in between these two because that's the first flex. Yeah? So there's an 8-foot extension goes between there and there. And then you put that up. And plus B goes there. In between these two, 8 feet, 8 feet, or 2 lots of 8 feet. You can put plus B with plus B like Lego. Yeah. So they just go in between those two. And then you have 55 feet reach. So, and what we're putting in there is high modulus carbon fiber. Now, actually, the tactical is already high modulus 1, 2, 3, 4. So it goes 1, 2, 3, 1, 2, 3, 2, 3, 4 is all high modulus in a tactical. All right, that's the difference between a tactical and a mini. Is the first 4 sections are actually the same as the Warrior or the Pro, right? Or were kind of thing. Okay, can you visualize that? You know, so that's an upside down 2-part extension. So it's 5 foot high, but when you pull it out, it's 8 foot long. So it adds 8 feet to the pole, and it's a more rigid material, so it prevents the pole from flexing by adding thinner sections. Does that answer that? Yeah. Great question. Yeah. So, and the reason we make it this way is because the 80-20 rule is the rule of business. You should always know the 80-20 rule. And 80% of the glass that you clean is usually 2 stories and below, or 4 stories and below, depending if you're a residential or commercial. So let me just, if that's wind is blowing, I'll just lock that in there. So if 80% of the windows you clean are 2 stories and below, then you should focus everything about your efficiency thinking at 2 stories and below. And later, you can think about efficiency above 2 stories, because that's only efficiency on 20% of your work. Right? So if you can become amazingly fast at 2 stories and 1, but our brains want us to go and buy a 5-story pole and get really good at the 5th story. And we forget that when we've finished the 5th story, we're now cleaning the 4th story, and when we've finished the 4th story, we're cleaning the 3rd story, and the rest of the building is 2 stories and below. And the same with those of you who do commercial, 4 stories and below. Like 5 and 6, don't worry. Get a pole that can reach there. Like, you don't want to lose everything in flex, so I'm not talking about being ridiculous about it, but don't focus on having the longest pole. All right, it's not a competition. Right, if you know what I mean. It is not about that. It is simply, so we get, everybody goes, I want to just buy the longest pole you've got. And I go, dude, like, don't buy the longest pole, right? Just tell me about your business. Let's get you fast up to 80% of the glass. And we've got extensions that can take you as high as you want to go. You don't need to buy them today. You can buy them anytime in the future, right? But it's no use doing the first piece of water fed at 7 stories and thinking you're a hero. Right? Now, I've had guys who have won a 7-story building, and it is the first job they've done, and I've spent an hour on Skype with them, like Remy in Canada. His first job was 7-story hotel resort, monstrosity of a thing. And I'd spend him, and I went through him all the science and all the physics and all what to do if the wind blows this way and all what to do, setting up the goosenecks and what angles, and because if you're at 7 stories, your pole is flexing like this, and then you come to 6 stories, and the pole flex, because of the rigidity of the carbon fiber, springs out, right? So the pole flexes completely differently, and then by 5 stories, the pole's stiff and straight again. So it's gone from the top section being almost parallel to the glass to being a straight line just from 7 to 5 stories. So you've got to know, it's ideal to know what's going on at 7 and 6, and then 5 down is straightforward. Or if you're talking tactical, it's ideal to know what's happening at 5, and then 4, 3, 2, 1 are all straightforward. Okay, so you can always call me up if you haven't done high work, because a building like this, if this was another story higher, or 2 or 3 or 4, then we could be sitting here saying, oh, what a lovely day. Meantime, there's a 40-knot wind blowing across there, and you've got your pole up there, and you're standing here thinking it's wonderful, and then all of a sudden the top of your pole's being taken out. Who's had that happen? Yeah, us, yeah. So then you start losing poles with a death zone of 65, 70 feet away with a pedestrian, yeah? By the way, if that does happen, right, I'll tell you the trick. If you have a wind blowing this way, taking your pole that way, turn your hand that way and corkscrew the pole. And you'll corkscrew the pole and it'll straighten up and become stiff in the wind. Right? So it's really nice, if you get the chance, it's a really nice thing to be able to do.
Say that again, Barry. Say that again.
If you've got the wind blowing this way, so the pole wants to go that way, you want to corkscrew, so you're going to turn the pole this way. So you're going to add a corkscrew into it going back that way. So you're corkscrewing it into the wind. Right? Let's talk about, that's rotational torque, so which is carpal tunnel, right? So you always try and think every time you do something what you're doing, you know, so you don't build bad habits. But the other thing that you'll see coming into the market now is out of round poles. So we should talk about those and say, what's the benefit? Is there a benefit? And so from a construction point of view, if you have an out of round pole, the way it's made, these have a mandrel or a mold, right? So there's just a steel mold, and then the carbon fibre is wrapped around it, then it's taped up under pressure, then it's cooked under pressure, and then the tape comes off, and then we sand off the ridges so that it doesn't make any noise, and you've got a flat surface for your clamp to grip on, and then that becomes your pole. Now, a circle is really strong as a shape, yeah? Like an egg is strong and a circle is strong. And so when they make the mold for the out of round, what they do is they make a circle mold, which is easy on a lathe, then they mill a straight side, that's easy on a mill, and then they run a radius, right? So you haven't got a sharp corner, because that's completely a weakness, yeah? If there was a sharp, right, if there was a like close to 90-degree angle there, it would be like it would just crack immediately. So they run a radius on that, right? Maybe 5 millimeters or something like that. But that point, that radius, is that whole corner is a weakness. So in order to compensate for the weakness of not having the strength of a circle with all your most of your fibers running linear up the pole, then they have to put more layers around the pole to hold it together so the corners don't crack. Right? And that's why if you read the feedback on it, it's a softer pole. Or they'll say, oh, it's made from high modulus carbon fibre. They have to make it from high modulus carbon fibre to make it even behave like a normal modulus carbon fibre, because more layers are holding it together. Why did they go out of round? Is because of rotational torque. So you've got to twist the pole. Now, when I was doing window cleaning, right, with my B-cam brush, so when we had brushes and we're cleaning at great heights, let me grab the Warrior. What's that?
That's cool.
Yeah, I'll see if I can demonstrate it here. Okay, so we're cleaning at great heights and we don't have a constructor brush, right? So what we would do, because we're exhausted by now, right, is we would come across to the frame. Let's say it wasn't a frame deep as this, but if it was a frame and that wasn't a swivel, right, we would then lean, I'll try and show you what we do, we'd lean the brush up like this. Do any of you remember that? Any of you still do that? No, we would squirt the 2 pencil jets across from the frame, like basically, if that was a window there, right? If that was a window, we would have the brush like this and squirt the water across there because we're getting tired. So we knew we should have been doing this, but that's really hard to control. Yeah, so then we come down that side and then we come down that side and try and squirt the jets. But we're actually leaning it up. So then you're using the rotational torque and the grip of the clamps to twist the brush up on its side so that you can squirt the water across. Now, if you have a look at constructor brush, right, when constructor brush is up there and you twist this pole, every effort that I do from rotational torque from my carpal tunnel is transferred in a straight line to side swivel. There is no load. there's no rotational torque load on a rinse bar swivel brush pole. So there's no reason, they're solving a problem that only exists if you only use the old method, which should be gone in a year or two once everybody kind of gets the science of why this works, yeah? So that's, I just think that the out of round pole solves a problem that is no longer a problem, and there's definitely no load like on a swivel, because the swivel takes any rotational torque, so what's the point of having a pole that doesn't rotate if all you're doing is moving a brush like that?
Especially if you've got a rinse bar, right?
Yeah, yeah, if you're leaving the brush on the glass, you've got no load, you saw how difficult it was even for me to demonstrate, because the swivel was taking up anything I tried to do rotationally, the swivel was just taking it up effortlessly, you know. So, that's my pitch on out of round, right? What else do you want to know about carbon fibre 2019? There'll be 3-section, right, and then they'll be compatible with grip. Do you know what grip is? So, every reach-it pole has the number 1 section pull out, right? So there's 2 reasons we have it. Either for max reach, which Peter Thomas is the world's leader in max reach. Could you run in and grab max reach? You think? You saw in the tactical box? So we'll show you what max reach is. But you can't imagine, we've got Peter on video cleaning windows, how many, 12, 15 feet horizontal? 4 to 5 meters? 12 feet, 4 meters? 4 meters horizontal with his mini, I think, before he got a Warrior. So he's 4 feet horizontal over a plexiglass, is that the right word? Plexiglass awning, so he can't do anything, and he's got a river behind, an ocean behind him, right? So he's 12 feet horizontally with this max reach and cleaning windows from the ground. He couldn't climb up on it anyway, like nobody could clean that window. Nobody, except Peter Thomas. Yeah. So, because all the reach-it poles have the ability to take the number 1 section out, then that means that we can also use the number 1 section as a ground pole, right? So this is grip, you can plug your tube in here, pop it through there, add your brush to it, and then if you're doing full fencing, glass balustrades, you know, you can clean over the glass balustrade, center of gravity is on this side, yeah? And then on this side, you know, pretty much like this. We're developing a negative angle swivel head, like side to side doesn't go into a negative angle, most of you have noticed that. Then we're developing a new one that'll go into the negative angle, and that'll make it easier for you to clean below your knees with a constructor brush. Yeah? Because that's a problem right now. You kind of got to go this way. You want to go this way. Yeah. So we're addressing it. Maybe 6 to 8 weeks. Yeah. So the traditional pole. So everybody who owns a reacher has got a little traditional pole, and then for the other side we've got a 3-section. It'll be 4 feet, 8 feet, and 12 feet. 3 different poles, right? So extended length. And then the handle will be Kevlar, because carbon fiber and aluminium have a problem in the heat. They become hotter than the ambient temperature, and in the cold they become the ambient temperature, which is like in North America is pretty damn cold, right? Like -20 and stuff like that. So Kevlar doesn't conduct electricity, doesn't conduct heat. So if we put a Kevlar handle on, then you'll be able to, you know, hold the pole, and then it won't heat up under your hand in the sun. So that's kind of like our little, what we think is a benefit. You know, it's still lightweight, still, you felt how light that shock stop is, right? So it'll be lightweight, and then 3 different lengths, and then we'll put some sort of fittings on the top so you can get your gear on it. Yep. So, max reach. So all reach-it poles are designed for this function. where we have two sets of goosenecks. One's called HTG, like heavy duty gooseneck. And heavy duty gooseneck is just if you have some architectural obstacle, which is like, 20, 30 centimeters, something like that, maybe 40, and you just want to get over it. Yeah, or you want to set an angle. Like if I was, here's another example. If I had a walkway here, so I've got a 1 meter walkway with a townhouse or something, and they've used a brick on its end sill, so I can't get straight line access for the brush to the glass. So then you could drop a gooseneck, like a little HTG gooseneck in, and it'll give you that extra length to be able to, get in here and get straight at it. So it's got 95 degrees, 110 degrees, 125 degrees, and 140 degrees in that set. But the more exciting one is HTG. No, max reach. So this is for max reach, so you would just drop that in there. And then,
You probably don't need that one, Pez. Probably use the one that has the brush on it.
Okay. It's not quite the same because we wouldn't normally have the side to side on it, but the point will be there. Pull it on. Right, and then we would normally have instead of the side to side, we'll have a straight fitting, so the brush is pointing straight out. Yeah. And then we can clean windows directly out. 6 feet with a Warrior, 7 feet with a Pro, 5 feet with a Mini or a Tactical. Yeah, so you can get over awnings. Now, how did Peter get to 12 feet? Yeah, or how do you get to 4 meters? Well, because he has, he must have a Mini, mustn't he? Yeah.
Mini plus A.
Yeah, so you can take the Mini plus A, which goes between the 1 and the 2, and you can put the Mini plus A in between here. So he's got Mini plus A, 8 feet plus 4 feet of this, a couple of overlaps, and he's out 12 feet. Horizontally, cleaning a window where Harrison is. Yeah, but the key to it is rigidity, right? As if this pole was floppy, not gonna happen, he ain't cleaning no windows, yeah? So that's why we know that there's an upside in just making the best. I was talking to somebody yesterday, like we throw away stuff that we could just keep selling, but we throw it away and say, no, we've already worked out how to do it better, so we just keep pushing the line to give you the best, because what ends up is you can reach windows that other people can't reach. This setup here, actually with this window, if you look at glass awnings over pedestrian walkways and strip malls, what do we call them here? In America they call them strip malls, but I didn't know what they were talking about when I first talked to them. The glass above your head when you're walking beside the shops. He's my man. So this, you can get, this up, and be cleaning that from the ground as well. Right, nice and early in the morning. Yeah. So, how's that? How's my time? Did I do a 50-minute run?
Yes.
Great. Any
More.
questions on goosenecks, pole compositions, pull apart, structure? Did I cover everything?
I think so. The clips on the outside of those, to take the pipe, to take the hose.
Yes, you've got a nice little, we call them tube runner, yeah? So you can just slide the tube. You can run tube internally with a reach it, but if you want the pull apart function, then you've got to choose to have the tube external to make it efficient, right? And if you do buy a pole that has tube internal, the chances are that the manufacturer is trying to sell you another pole that's longer because he's trying to use that tube to persuade your brain that that's the length of that pole. So they don't want to sell you plus A and plus B logic, right, even though it makes sense. And secondly is that you'll often see that the surface of a pole is corrugated, and then the tube is internal, which will bring the dirt and the grit into your pole. The dirt and grit gets caught between the clamp and the corrugations, right? And corrugations wear faster than flat surfaces, right? So then it wears down the corrugation. If you can wear down the surface, the outside diameter of your tube, you can't replace the clamp and make it better. Because the clamp is only going to clamp on whatever. If you make what it's clamping on too small, it'll never clamp onto it. So then you need a new pole. So therein lies the Nokia thinking of the English style poles, right? Replace a pole every 2 years. Wear it down with with dirt and grit with an internal tube and corrugated surface. Yep. So we go the other way, right? We say sand the surface, give it flat, put the tube on the outside so you don't get dirt and grit. Give you a pole cleaning kit so you can clean it once a quarter or once every 6 months or after you've been on a sandy job or whatever. You know, so you've got a chance. And then this is the same material they make Boeing Dreamliner out of and professional golf clubs out of. And if they were meant to be replaced every 2 years, they wouldn't exist out of carbon fibre. And there's no reason why a waterfed pole should be replaced at all.
So
Yeah.
the flat hose I saw in the desk there, that
Yep.
won't fit on that bit of stuff?
No, I'll show you the high flow does, right? The blue one. Yeah, so we're going to talk hose and tube and all that next. All right, got a head full. Let's take a 10-minute break, have a chat, and you can have a touch and feel, lift them up, and then we will get into ROs and DIs.